Forces in equilibrium means two things. It means the resultant force in any direction is zero, and also if we take the moments about any point, the anticlockwise moment will cancel out with the clockwise moment, so the resultant moment will be zero. But we're not looking at moments in this video, we're just looking at resolving forces in any direction where the resultant force will be zero. So here's example 1, and we have a vertical force Q, so we're going to leave Q alone, and we're going to resolve the P newtons and the 4 Newton force into its horizontal and vertical components. How to do that was shown in a previous video, but I'll go through the process again here. So as I said, we don't need to do anything with Q, we're just resolving the 4 newtons and the P Newton force. And to do that, for the P Newton force, its horizontal component and its vertical components will be, well, the horizontal component is the adjacent side to the triangle, so that's P cos 30, and the vertical component is the opposite side of the triangle, so that will be P sin 30. Similarly for the 4 Newton force, the adjacent side of the triangle will be cosine, so it's 4 cosine 45, and the opposite side will be 4 sine 45. So now we've resolved each of the two forces into their horizontal and vertical equivalent component. Now we can put all the forces back together again, and therefore we have horizontal and vertical components that look like they do on the diagram, and because the forces are in equilibrium, the vertical forces will cancel out and the horizontal forces will cancel out. Therefore, horizontally, we have P cos 30 equaling 4 cos 45, and therefore we can obtain P. Vertically, P sin 30 plus 4 sin 45 equals Q, and therefore we obtain Q. In example 2, we have 4 forces. The 3 Newton force is horizontal, so we'll leave that alone for the time being, and we'll resolve the other 3 forces into their horizontal and vertical components, starting with the 9 Newton force. Its horizontal component and vertical component, well, the horizontal component would be the adjacent side, so that's 9 cos 40. The vertical component would be on the opposite side of the triangle, so that would be 9 sin 40. For the 8 Newton force, its horizontal component relative to the 20-degree angle here, that horizontal would be the opposite side, so that's going to be 8 sin 20, and the vertical component is the adjacent side, so that would be 8 cos 20. And finally for P, the horizontal component is the adjacent side, so that's P cos 40. Relative to the angle theta, that component, the vertical component, will be the opposite side, so it's P sin theta. We've also got the 3 Newton force, so don't forget about that, and we're going to put now all those component forces together. And when we put them together, this is what it will look like. The horizontal forces to the right, we've got 3 plus 9 cos. The vertical components, upwards we've got 9 sin 40 plus sin theta. Downwards we've got 8 cos 20. And then horizontally 8 sin 20 plus P cos theta. Now the vertical components will equal each other, they'll cancel each other out, the horizontal components will cancel each other out, so we're going to be able to find P and theta. So horizontally, we have that situation where those forces cancel each other out. The only unknown there is P and theta, so all we know is P cos theta equals 7.158, and we'll just leave it at that for now. Vertically, we have 9 sine 40 plus p sine theta equaling 8 cos 20. And therefore that gives us p sine theta equals 1.73245, etc. So now we have two